9. Tropical rainforests play a role in maintaining biodiversity and in storing carbon. So, could be a bit of topic 4, could be a bit of topic 5. In a mature tropical rainforest, there is no net increase in biomass. Which statement describes the role of photosynthesis in the carbon cycle? Carbon dioxide is oxidized to form organic molecules. So oxidation happens during respiration. And remember that in the Calvin cycle, we have the first stage, which is called, what is it called? Oh, there's 3 stages. Forgotten what those stages are called now. Fixation, and then we've got reduction, right? And then we've got regeneration. So reduction is the way to go. So carbon dioxide is reduced to form organic molecules. We're going to go with B, not that one because it's not oxidation. And organic molecules are produced in photosynthesis, so it's not either of these. Okay. The gross primary productivity, GPP, for one mature tropical rainforest was found to be, right, okay, it was estimated that 65% of GPP was used in respiration. Calculate the energy transferred to the next trophic level. So the energy transferred to the next trophic level would be NPP. So if they're telling me that 24,800 kilojoules per meter squared per year is equal to GPP, and that 65% of that was R, respiration. So remember, NPP equals GPP minus R. So what is 65% of that? I'm going to get my calculator. So 65% of that, so 24800 times 0.65 equals 16120. So 65% of that equals 16120, okay, which is then equal to R. So 24800 minus 16120 equals N equals 24800 minus 16120 equals 8680, and the units are there. So we move on. Explain how reforestation of tropical rainforests can be used to minimize climate change. Explain how reforestation causes minimization of climate change for 3 marks. Okay, so there's a lot of because and this causes that, and and addressing a lot of why. So why? So if we say one thing, we say why we're doing that, and why we're doing that, and why we're doing that. Okay, reforestation. So let's think. Reforestation would do what? Why? Okay. So we've got reforestation. Reforestation requires or allows growth of new trees into forests. Okay, so the key thing being growth. Growth requires fixation of carbon from atmosphere into the biomass of trees, growing trees. Okay, growth requires fixation of carbon from atmosphere into the biomass of growing trees due to photosynthesis. Okay, this would result, so carbon dioxide would be removed from atmosphere, and remember that CO2 is a greenhouse gas. Okay, but it does say climate change, so because it's a greenhouse gas, it would reduce, which would reduce atmospheric temperature. So I think we've fully explained that. All right. C. Information on biodiversity has been collected from various rainforest habitats in Madagascar. Describe what needs to be measured in order to compare the biodiversity of two rainforests. Describe what needs to be measured. Okay. Now remember, biodiversity can be species and it could be genetic. So in order to get the species diversity, we would need to record for species biodiversity, we would record number of species present, and the abundance of each species, population size, of each species. Okay, so remember Simpson's index equation, which has just flown away from my mind right now. But in order to measure that, we do need big N and little n. So for that, we do need the abundance, the population size of each species. Okay. For genetic biodiversity, right, we need to measure the number of heterozygous individuals in each population, okay, or measure genetic variation, basically. All right, okay, I think I'm happy with that. Okay, the biodiversity of the land area of Earth has been estimated. The table shows information on the number of species of plants and vertebrate animals in the rainforests of Madagascar and for the land area of Earth. Okay, so we've got two regions. So I always read a table from the left and moving then towards the right. So we've got Madagascar versus the land area of Earth, and we've got plants then. First, looking at the number of plants, number of known species, number of known endemic species. Okay, so that's probably the total, right? And then of that total, how many of them are endemic? Yeah, okay. Right, land area of Earth, number of known species is 300,000. Number of known endemic species is also 300,000. It's kind of weird. Number of known endemic species. Oh, okay, right. land area of Earth. So this is the total. Okay. Total known species. What? It's not quite making sense. I'm not understanding that properly, I think. Vertebrate animals, number of known species. So why is the number of known species? Table shows information on the number of species of plants and vertebrate animals in the rainforests of Madagascar and for the land area of Earth. $300,000. Alright, fine. Let's just see what they want. This is weird. Analyze the data to determine the importance of the rainforest of Madagascar in maintaining the biodiversity on Earth. Okay. This is very strange. Okay. Or maybe I'm not looking at it right. The land, because what I'm thinking is Madagascar is part of the land area of Earth. So what we're doing is comparing Madagascar numbers to the land area of Earth. Okay. But I think what we're basically doing is saying, look how biodiverse Madagascar is, because even though it's got such a small land area compared to the land area of Earth, look how many endemic species it has, for example. Look how many different kinds of plants and vertebrates it has. So, but I'm not understanding what these numbers mean, because how can the total number of known species on the land area of Earth be 3,000 and the number of known endemic species of plants also be 300,000? That means every species is endemic on Earth. Oh, that makes more sense. Of course. Okay. So they're endemic to Earth. Bloody hell. FFS. Okay. That's making a bit more sense now. Okay, so, sure, even though now I know what that means, that is still weird, because how do you use that number? Okay. All right, maybe I'm overthinking this. Maybe we don't need to go there. All right, so the land area, let's compare the land area first of all. Madagascar, land area. So I'm just going to compare how much smaller Madagascar is, or what's the percentage of Madagascar land area. So I'm going to do 59,300 as a percentage of the land area of Earth. So 59,300 divided by 149 is equal to, very small, 0.04%. Madagascar land area is 0.04% of land area of Earth. Okay, so it's very, very small in comparison in terms of area. Okay, but total number of known species of plants, but has, so let's work out now a percentage of plants. Percentage of plants on Earth. Okay, so if we work out the total number of plants, so that it has 12,000 divided by 300,000 equals 100 equals, but has 4%, but contains 4% of total number of known species. Okay, but has 4% of the of all known plant species. Okay, and of those 4%, we could do then a percentage of 9,704 divided by 12,000 times 100. Okay, and it's about 80% of those. So 9,704 is 80% ish of 12,000. So it has 4% of all known plant species, and 80% of those are endemic to Madagascar. Okay. And in terms of the vertebrate animals, so vertebrate animals do a similar thing. 987 divided 27,300 equals times 100 equals. So, and has 3.6% of all known animal species, of which 771 divided by 987 equals times 100 equals 78% are endemic to Madagascar. Okay, so that's a bit descriptive. So maybe I will just, because sometimes just for describing the data, you can't really get the marks for that all the time. So you got to kind of make a judgment. So my judgments would be Madagascar has a much higher density number, density, let's go for density, much higher density of species in comparison to its land area, and it has a high proportion of species that are only, so I'm just adding value to the term endemic, that are only found in Madagascar. Okay, I don't advise going outside of the writing space because sometimes that might get clipped off, so just be careful. I'm writing on a very tiny iPad here, so that's my excuse. All right, that's question 9, last question, come on.